Okay. Um, Good evening, everybody. I am Dr. Bourne, Dr. Sierra Bourne. I'm the Chief of Staff here at Northern Inyo Healthcare District, and I'd like to introduce tonight Elizabeth Haun, a nurse practitioner at Rural Health Clinic, for a healthy lifestyles talk tonight about the gut microbiome. We're calling it Go With Your Gut. So, without further ado, I'll let Elizabeth take it away.
Thank you. Okay, let me share my screen. There we go. Okay. Um, my name's Elizabeth, and I'm here to talk about the gut microbiome, and not only that, but how it relates to our overall health, especially with our brain, because we do have a connection between the gut and the brain. So I put this question out here because apparently, from what we learned, and this is a new kind of cutting edge science that we're learning about how the gut functions and the brain, how it's connected to the brain and the rest of our body. And apparently, we are made up of billions of bacteria, yeast, and virus and protozoas. We have them in and around us, and our cells contain bacteria that eons ago was trapped, like our mitochondria that helps us generate energy for our cells. And it's just over the evolution of our species, we've just lived with all of these bacteria, yeast, virus, and protozoas and other things, and have incorporated them into our bodies to make more efficient function and living. So I'm going to start with the digestive tract. And there's a picture here. It's just a very simple picture of our digestive tract. And it's basically a long tube that's coated with mucus and bacteria, which covers a layer of rosy skin. And then around this tube is a complex mesh of nerves, veins, arteries, lymph vessels that are loosely bound by elastic tissue. And then there's an outer layer of muscle. So this little picture just kind of shows how complicated it is. There's multiple layers and lots of stuff going on in there. And each one of these areas, just to break it down a little bit, the mouth is where we start the digestion and the breakdown of food, mechanical and chemical, mechanical with your teeth, and chemical with your saliva that's got all sorts of stuff in it. The esophagus is about 8 inches, and it's just a tube for your food to drop from your mouth and throat down into your stomach. And then in the stomach, we have really powerful acids. I have here like battery acid that continues to break the food apart, mixing it, and your stomach kind of moves around and it creates a ball of this chunk of stuff that then drops down into your small intestine. And there's actually very few live organisms, good or bad, that can survive this acid bath. The small intestine then is about 1 inch round, and it's about 23 feet long. And this continues to break down the food with enzymes from the pancreas, as well as bicarbonate to neutralize that acid so the acid doesn't eat through the small intestine walls. And much of the nutrient absorption in from our food takes place here in the small intestine, including easily digestible sugars. The large intestine is wider. It's about 2 inches. It's about 3 feet, a little over 3 feet, and it has all sorts of cracks and crevices in it that get filled with bacteria. And we end up in our colon, our large intestine, with about 1,000 different species of bacteria. And then, the anus, we know what that's for. And up to 60% of the dry weight of our poo that comes out of our anus is composed of bacteria. And basically, that's why it smells so bad. let's see. So the role of the bacteria in the colon or the large intestine is it stimulates the cells in the colon wall to secrete more mucus, which is what is a good environment for the bacteria. They like to congregate and create these grouping of bacteria, and they like to live in the mucus. So they create their own environment in there. It can improve glucose tolerance. It can calm the immune system. And let me just back up a little bit. When I refer to bacteria in the colon, I'm referring to the good bacteria. So we live with a normal group of bacteria, and we want that to be good bacteria, because if you get the bad bacteria, that's when you get sick. That's when you have diarrhea, dysentery, bloating, gas, discomfort, potentially even Crohn's and irritable bowel syndrome. All sorts of stuff can happen when you have an overgrowth of the bad bacteria. So when I refer to bacteria, I'm going to be referring to our good bacteria. So this can calm the immune response in terms of Crohn's or IBS or any kind of inflammation in there. They can modify certain genes in our brain, from the gut to the brain, which encourage repair of cells and potentially can lead to better mental health. They help to synthesize B12 and other B vitamins, as well as vitamin K, to make these. The bacteria help to make these vitamins. The bacteria in the gut can also secrete neurotransmitters, and the bacteria provides a barrier between the outside and the inside. And so anything that passes through has to go through this bacteria barrier, which helps protect the health of the colon. I'm just going to go over a real quick review of the brain now, since I did the GI tract. And we have all these nerves, and you don't have to know much about these nerves, but we have these nerves that come out of our skull, and there's 12 of them, and most of them are used to innervate the face, the movement, your eye movement, your pupil size and movement, and your tongue and your throat. But there's one nerve, the vagus nerve, it's cranial nerve number 10, that comes out of the skull and goes down through your organs and wraps around your intestinal tract. And so this is the road that goes between the brain and the gut, that is a two-way communication mostly because of this one cranial nerve, number 10, the vagus nerve. And this is just a quick view of what the vagus nerve does. So as you can see, it comes out of the skull and goes down, and it innervates some portion of the lungs and the heart and the liver and all of those other organs in there. And then, like I said, it wraps around the whole digestive tract. It's just to give you a visual on that. So one thing I need to talk about real quick is neurotransmitters. So basically, neurotransmitters are a chemical compound that pass information from one nerve cell to another. So as you can see in this drawing here, there's two nerves that are coming together, and they don't actually touch, but they send these neurotransmitters back and forth, and that's how nerves can talk to each other. And some examples of these neurotransmitters are, some of them you may have heard of. There's acetylcholine, serotonin, dopamine, GABA, epinephrine, and some amino acids. So some of these neurotransmitters are activating and some of them are calming. So the vagus nerve comes from the same Latin root as the word vagrant or wandering. So this kind of describes the vagus nerves, how it meanders through our organs of the torso and around the digestive tract. And it reaches all parts of the digestive tract from top to bottom. And so the bacteria in the gut, like I said, they produce neurotransmitters. And so the bacteria in the gut, they secrete, so they produce and release neurotransmitters as well as pick up neurotransmitters from other nerves and respond to them. So it's a two-way communication going on here. We don't fully understand the effect of the neurotransmitters produced by the gut bacteria on the brain. However, mostly because the blood-brain barrier is pretty tight, and so these neurotransmitters produced in the gut don't pass into the brain. However, they can communicate with this vagus nerve and stimulate it or calm it down. So it's possible that the secretion of these neurotransmitters in the gut will touch the vagus nerve and then create situations in the brain. So there's still a lot that we really don't know about this. This is really just kind of a new, interesting thing that we're learning about. So the next thing, I just want to talk about a couple of the nervous systems, 3 of them. You've probably heard of the sympathetic and parasympathetic nervous systems, or the sympathetic being the fight or flight, and then the parasympathetic being the rest and digest. So involved in that as well is the enteric nervous system, which is the nervous system that operates in your gut. It kind of has its own set of rules and it does what it wants. One example of this is when you eat something and we have what's called peristalsis, which is the movement of the food through the digestive system that kind of pushes it down to the colon and then out through the anus. That's peristalsis. This is done in the gut. It doesn't need direction from the brain to do this. It just kind of does it on its own. And so this nervous system, this enteric nervous system in the intestines can be referred to sometimes as the second brain. And the vagus nerve is a big part of this in the two-way communication between the brain and the gut when it's needed. Okay, so let's talk a little bit about the gut-brain axis. So we're still learning a lot about this. There's still a lot that we don't know about it, but so this gut bacteria or microbiota can communicate with our brains through 3 different pathways: the neural pathway, which includes the vagus nerve, the immune system, and the endocrine pathways. So, and can influence the brain's function and behavior. Likewise, the health of your brain can affect the health of your gut. So the nervous system relays information through the vagus nerve, through neurotransmitters, which I talked about. The immune system will mount a defense response to threats via the blood system and stuff that the blood and other parts of your body produce. And the endocrine system, which manages growth and metabolism, communicates through hormones. So these are a kind of a chemical signal like cortisol or insulin. Those are both hormones. So those are the 3 different ways that the pathways that can influence our brain. So if we talk about the effect of the gut on the brain, or the gut itself, and how to promote this good bacteria that I've been talking about, the main thing that bacteria love is fiber. Fiber is manna for bacteria living in the colon. And so the byproduct of the bacteria, the good bacteria feeding on this fiber, has a surprising amount of useful fuel for us. One of the things that I remember somebody telling me was that when a baby's born and they're breastfeeding, the majority, I think it was 80% of the breast milk from the mother is indigestible by the baby, but is digestible by the bacteria in the baby's gut. And so that bacteria in the baby's gut is what's producing a lot of like the nutrients and stuff that the baby actually needs. So a healthy gut helps you to maintain what we call homeostasis, which is when your body's in a really good balance and you're healthy and you feel good. A dysbiotic gut, sorry, lets pathogens or bad bacteria through the barrier, and that's kind of when you get sick. So when your good bacteria balances off, then it allows the bad bacteria to grow and you get sick. So depending on what you eat, you encourage these blooms of different bacterial species that create a good balanced homeostasis in your gut. And between meals, you kind of have this core group, but then when you eat, they change and they evolve and they grow and die off. And so it's very liquid, fluid thing that's going on in your gut, no pun intended. But it's changing all the time. It's hard to track, actually. And that's one of the reasons why it's hard to study, because it's so fluid. So fiber is the OG of prebiotics, and prebiotics are basically what are going to feed this good bacteria in your gut. And it will, believe it or not, you can overdo it by taking too many probiotics. And so eating a lot of fiber makes it so you don't have to take so many probiotics and overdo it. Fiber is really good at surviving the acid bath of the stomach. So, and when you take probiotics, they often, a good portion of it doesn't make it past the stomach. What does make it past the stomach is something that, probiotics that are attached to in little corners of the food or something that's going through your stomach and down into the small intestine, but most of it doesn't survive. So refined grains are not prebiotics. So if you're like white rice or white flour, the bran that's removed around these is they're basically taking the prebiotics off of the fiber for, so it doesn't do your gut any good to eat it without it. Oops. So there's soluble fiber and insoluble fiber, and I'm not going to go too much into that, but the main fiber that is the most beneficial for these gut bacteria is what they call the resistant fiber or starch. And this is a fiber that we absolutely do not digest ourselves, that we need these good bacteria to digest it. They like it. So these are some examples. Very few examples. I have more down below, I think. So here's, so this is some interesting information about probiotics. Most probiotics, such as in yogurts, don't naturally dwell in our guts and are considered transient. So I kind of referred to this transience earlier, when you have your core bacteria that you have in between meals, but then when you eat something, it can change and grow, and that's considered the transient bacterias. There are products out there that claim to do too much because, like I said, fewer than a third of bacteria will survive the acid bath of your stomach. This is something that's not regulated by the FDA, and we don't know what the ideal dose is. There are some probiotics that I have labeled here that have been researched, and so they do have a little bit more information about these specific probiotics, and I've got some of the guides there. There's also an app. There's an app for everything, right? Called Clinical Guide to Probiotics, and it's excuse me, created by a registered dietitian in Canada, and there's the Canada version and there's the United States version. So excuse me. Okay, moving on. So here's some do's about feeding your gut bacteria, the good gut bacteria. So fiber, like I said, so whole grains such as quinoa, brown rice, bulgur, whole wheat, dry beans and other legumes, nuts and seeds. Foods rich in prebiotic fiber. So the prebiotic fiber is what's going to feed the the good bacteria, and these are Jerusalem artichokes, chicory, endive, lentils, asparagus, beans, blah, blah, blah. Bananas is good, has a good resistant fiber, but the greener the better. So if you like your bananas green, that's good. You get a lot of resistant fiber. And this is all over the internet. You can research, you can just put in resistant fiber or resistant starch and get all sorts of information about it. Diversity is best. The greater the diversity in your diet, the greater the diversity of your gut bacteria. And that's what we want. We want diversity. We find that people who eat the same stuff all the time have the same bacteria, and it can be very limiting. And what you want is you want a diversity, because that diversity is what's going to help you to fight off any bad bacteria that ends up in your gut and can make you sick. Exercise also improves your gut bacteria. Surprise, surprise. So these are the don'ts. Junk food and processed foods, that's the kind of thing that's going to feed the bad bacteria and limit the amount of good bacteria that you have in your gut. Fresh is best. Less sugar, less alcohol, because of the sugar mostly, as well as for other reasons. Emulsifiers, these are things that I have a couple of names of some of them down there that I can't pronounce, but this keeps water and oil basically from separating. It kind of combines different kinds of foods to give a certain texture. And then try not to take antibiotics. Obviously, if you need them, you'll take them, but if you don't need them, don't take them. So other things that affect the gut microbiome are infections, inflammation, chronic stress, overuse of painkillers, continuing or repeated rounds of antibiotics, excessive alcohol use, autoimmune disorders, gluten and other food sensitivities or allergies, radiation or chemotherapy, overeating, and lack of exercise. So like I said, we're still doing a lot of research on that. There's so much that we don't know. And so they're starting to think that there's strong correlations between certain health conditions and what they call dysbiosis, which is basically you have an overgrowth of bad bacteria chronically in your gut. And so I say may because it's a big may. We don't really know for sure, but they're starting to see indications that potentially your diet is linked to these conditions that I have on this slide: irritable bowel syndrome, Crohn's, and ulcerative colitis, depression, because of the gut-brain axis. The gut affects the brain affects the gut. So if you have an overgrowth of bad bacteria in your stomach, it can make you potentially depressed, anxious, stressed, and likewise, if your brain, like if you're stressed or you're having, you're depressed or you're having problems in your personal life or whatever that affects your brain, it can also affect the gut bacteria in your gut because of this communication with the vagus nerve. Can potentially cause eating disorders, obesity, not cause, but not help at any rate. Diabetes, dementias, autism, chronic fatigue, migraines. So these are just some of the conditions that they're thinking may have a link to and may see some improvement, not necessarily a cure, but potentially some improvement by improving the good bacteria in the gut. So, there's a lot of research being done on all of this, and it's kind of a little, it's very interesting, the stuff that they're trying to do. And so there's a future in this, and they're trying to figure this out enough so that we can address some of these conditions with food and improving the gut bacteria. And some of the things that they're looking at is, I don't know if anybody of you have heard of the blue zones, but these are areas, and there are pockets around the world they call them the blue zones, because in these pockets of areas around the world, there are people who routinely live to be healthy over 100 years old. And I think there's one in Japan, there's one in Southern California, Loma Linda, there's one in Italy on the island of Sardinia, and there are probably a dozen others that I don't remember. And so they're really studying these blue zones, and some of the things that they have found that these groups have in common is their diet and the amount of exercise that they get. So it's, copying the lifestyles of these blue zones would, they're finding that this potentially could be a future. And there's actually a blue zone movement. You can bring in a group that specializes in blue zones, and they'll look at the area like your town or your city, and they'll try and create more of a blue zone for people, for the community. Also, one of the things in the future is that looking at these good bacteria, that potentially they can use these good bacteria to create more targeted antibiotics to target bad bacteria and not the good bacteria. So we're learning about that. We're also learning about potentially creating viruses or choosing viruses from the environment that will target and attack the bad bacteria, as opposed to taking antibiotics, which wipes out all the bacteria in your gut and then you have to start over again. They're also talking about fecal transplants. I know it sounds kind of gross, but they take basically poo from a very healthy person that has a very diverse number of bacteria, and they put it inside of you. Don't ask me how they do it, but they do it in a very sterile way. So they're having success with these fecal transplants for people with irritable bowel and ulcerative colitis and Crohn's disease, and finding they're having some pretty good success. And then the microRNA, honestly, I just put that in there because it was in something I read, but I have no idea how they do it, but they're working on it. And it's something our gut already produces, and it's something that we would be able to use to create vaccines and stuff against the bad bacteria. And also, genetically engineered bacteria, that has its own controversies behind it. But if they can genetically engineer bacteria to remain in your gut and do healthy things as opposed to bad things. So let's see. So I started with the woman's belly. I just wanted to end with the guy's belly, that, the future of medicine is in the gut. I think that that's something that we need to think about. We all know that diet is good, and this is just one more reason why we should focus on a healthy diet and exercise, is that gut-brain connection that, we're just learning about. So anyway, I'm done if anybody has any questions.
Thank you so much, Elizabeth. Very interesting. First, there was a question from Udama Sharma. How
Okay.
does bacteria in the colon improve glucose tolerance?
That's a good question. And I'm not sure I can answer that. I think that, and if there's anything that you've heard about it, Udama, please, pipe in. I think it helps with insulin resistance, and if you have good bacteria in your gut and your brain is, and you've got that gut brain axis going, I think your metabolism with you let's see, I can't answer that question. I'll be honest with you, I can't answer that. That's a good question, though. I'll have to, for my next, if I do this again, I'm gonna have to. Do you have anything to add to that, Udama?
I will say I downloaded the app you suggested just
Yeah.
now, and it shows that there's level 2 evidence for, yeah, insulin decrease in insulin resistance for
Okay.
certain probiotics, but it didn't explain further than that. So
Yeah. Yeah. Well, I'll write that down, and I'm gonna borrow
Dr.
this.
Sharma said she was just curious.
Yeah.
Um, okay. Helene asked, any thoughts about the impact of meat on the gut?
Yeah. So meat in the gut, it doesn't necessarily. So it does help in that meat. We break down the meat into amino acids, and amino acids, some of them are neurotransmitters. So it does help with the communication with the gut, with the rest of the body and the brain. But it's not it doesn't contain the kind of fiber that's going to increase the good bacteria, basically. So it's good in one way, but not potentially in another way.
Thank you. From YouTube, a question, how long does it take the gut to recover after taking a round of antibiotics?
Maybe never. And again, this is still something that we're learning more and more about as we, hold on, as
Oh, we lost your sound.
can
Are
you
we
hear me
on
now?
hold? Yes,
Oh, yay. Okay.
very good. I don't know what happened there.
Yeah, me neither. So what was the question?
Oh, sorry. How long does it take the gut to recover after
Yeah,
taking a round of antibiotics?
right. Um, like I said, maybe never. It's really hard to tell. And this is something that we're really learning a lot about, because, like I said, you can take a bunch of probiotics, you can eat sauerkraut, you can drink kombucha, all the fermented stuff. But it really does take a long time to build up the bacteria after taking antibiotics. And it may actually never really get back to what it was initially, especially if you've taken a lot. But that doesn't mean you shouldn't try. Lots of fiber and all of those other things that I went through.
Um, Couple other questions. Are there ways to test or assess for the microbiome?
So there are companies out there that will test your microbiome, and I don't know how. Well, for one thing, I know that insurance probably doesn't cover them, so I don't know how much they cost. But I don't know how valid they are. I think that there's a lot of them out there that say they can do this, and I probably wouldn't trust it. But it's fairly involved because not only, I mean, they got to test like the DNA of each of these bacteria, and so when we have upwards of 1,000 in our colon, so I'm not sure they have some PCR tests that they're developing, which would make it more rapid. But there's so many bacteria, hopefully, in there that I'm not sure if they're doing it efficiently at the moment.
Thank you. Um, how does the gut microbiome change as we age?
So they've done some interesting studies about gut microbiomes in families. So because you have a population of bacteria in your mouth as well. And they're really starting to study this because they'll find that you have on the outsides, symmetrically, you'll have a certain colony of bacteria, but then on the inside, you have a bilaterally you'll have symmetrical other kinds of bacteria. So there are different areas of your mouth that grow different bacteria. And then they'll find that, which actually will, if you have an overgrowth of bad bacteria in your mouth, you can get a lot of dental problems. Whereas if you have good bacteria, you don't have as many dental problems. But they're finding that the bacteria in the mouth of a breastfeeding mother can get passed on to the baby, as well as bacteria and yeasts and whatever she's got growing on her skin gets onto the baby's skin, and it kind of passes through whole families. And so as babies, that's kind of how we get started with our gut bacteria. And so if you as a family start out with not a very good diet, and so your gut bacteria isn't great, then you kind of pass it on to the rest of the family and the baby, and they sort of start out at a disadvantage a little bit. And so as we age, really, I think it mostly depends on your diet. If you maintain a healthy diet throughout your life, you're going to have a healthy gut bacteria that's going to carry over into your older ages. And I'm not sure that there's been much research done on, the different ages, like as we get older, how it affects the bacteria, and, in terms of maybe the amount of neurotransmitters that the bacteria is always renewing itself. It's not like the bacteria gets old with us. So, yeah, I don't know. I don't know how it's going to get as we get into our 60s, 70s, and 80s. I'm not there yet, so.
Um, what I think you touched on this, but how can the microbiome um, play into weight management for those with obesity?
Yeah,
Or,
so this is really interesting as well, because because the bacteria can produce these neurotransmitters, for example, dopamine, which is the feel good neurotransmitter. If you are eating food like donuts and stuff, then you're going to be producing, the gut bacteria is going to be producing more of the feel good hormone. And so you're going to relate eating donuts to feeling good. So, in a way, the bacteria, if the whatever the growth of bacteria you have in your gut, they're going to create cravings that are going to make you eat things that they want to, for them to survive and grow. And so if you have a healthy gut bacteria, you're not going to be craving foods that are not good for you potentially. And this is the idea anyway. So in terms of like weight and stuff, if you have an overgrowth of bad bacteria that's talking to your brain, telling you to eat more foods to create more dopamine, like sugar and all this stuff, then then you're going to want to eat that, and you're going to gain weight. It becomes harder to resist it when you have these cravings. So that's one way that it can affect our weight.
excellent. I think we're just learning more and more about this field.
Yeah.
Um, do we have any other questions from the audience or YouTube? We'll solicit some now.
There's a lot of there are these pockets of, like, I know there's the University of Edinburgh in Scotland. They've got a big microbiome project going. I know there was one in Colorado, but there's these places around the world actually that have these big microbiome studies that are going on, and a lot of it's still on like rats and animals, but because this is really hard to test in humans, this kind of stuff. So, but they're continuing to study it and learn a lot. So it'll be interesting over the next, probably 10 years, what's going to come out of all this. It's going to be really interesting.
Fantastic. We gave a little pause, and I don't have any other specific questions, but that was so interesting, Elizabeth. Thank you very much. Um, for everybody else, a reminder that this can be viewed later on YouTube at the Healthy Lifestyle Talks for NIHD link. And thank you so much, Elizabeth, and everybody for participating.
You're welcome. Thank you to everybody.